Welcome to Pomodoro Joe for Thursday, May 11th, 2023. Today we're looking at LeetCode problem 1035, uncrossed lines. This is a medium problem. You were given two integer arrays, nums1 and nums2. We write the integers of nums1 and nums2 in order they are given on two separate horizontal lines. All right, so we have nums1 and we have nums2. We may draw connecting lines, a straight line connecting two numbers, nums1 index I and nums2 index j, such that nums1 index I is equal to nums2 index j, and the line we draw does not intersect any other connecting non-horizontal line. Note that each connecting line cannot intersect even at the endpoints, i.e. each number can only belong to one connecting line. Return the maximum number of connecting lines we can draw in this way. All right, so to summarize, we have two arrays of numbers. We stack them one on top of the other, and then we're allowed to draw lines connecting equal numbers from the top to the bottom. Now, once we draw a line, we cannot cross the line with another line. So for instance, in this case, we could not draw the line from 2 to 2 because that would cross the line from 4 to 4. All right. And our constraints. Okay. So with this, we'll put 25 minutes on the Pomodoro timer and we will get started. So we'll have some result and we'll set it to 0 to start and we will return the result at the end. All right, so with this, I think I'm going to do this recursively. I know you probably hear that from me a lot, but that's because I like recursive functions for this kind of problem. All right, so we have two rows, nums1 and nums2, and we can draw connecting lines between numbers that are the same. So what are our options here? Well, let's just start with our recursive function. We'll just call it max uncrossed lines recurse. And we'll take, I guess we'll call it, actually, we can make this whole thing a recursive function. Let's not even make this. Let's use our actual function as the recursive function. All right, so what's our base case? Now our base case here is if either nums1 or nums2 is empty, then we can't draw any connecting lines because they don't have any numbers. So that's our base case. And we can just say if not nums1 and not nums2, or I should say or not nums2. Then we just return 0. So if either nums1 or nums2 is empty, then we can just return 0. There's no way we can draw any lines here. All right, what's next? So next we have numbers in both nums1 and nums2, and we can optionally draw lines between them. So we basically have two options to start with, the big options. Option 1, we don't draw any lines. We just skip this number and move on. Option 2, we draw a line, but then we need to advance our nums. We need to essentially readjust our nums1 and nums2 to indicate that we have moved further down the line. So one thing to note is once we draw this line, so if we just go through nums1, for example, let's just go down the top row. Let's call that nums1. So we go down the top row. Once we find a number in the top row that we want to connect with a number in the bottom row, and we can connect with a number in the bottom row, we make that connection. We no longer need to worry about anything that came before that index in the bottom row. For example, with this 4, we connect this 4 to this 4. Now we no longer need to worry about anything below this 4, and including this 2, because anything in the top row that we go to next will have to come after this current index, and anything in the bottom row that comes before this connected index will definitely cross that line. So we only need to look at anything from this bottom index forward. That way we won't intersect this line. We'll just be in, not parallel, but we'll go in the same direction as that line. Okay, so that's one insight here. We have to sort of convince ourselves that once we make a connection, we no longer need to worry about any of the numbers to the left of those two indices on both the top row and the bottom row. Anything that came over here, we can ignore because all these numbers that come after can't go backwards to cross these lines. All right. Okay, so with that insight, let's just try our different options here. So option 1. Option 1 is we don't draw any lines. We take this first number and we just decide not to draw any line, and we'll move on to the next number. So for this one, we'll just do a recursive call. We're choosing not to draw a line, so we'll just call a recursive function, and we do need to change which numbers we're going through. So now our new numbers 1 will basically be from index 1 to the end. So we kind of decided, oh, we're taking this first number from nums 1, we're not even going to draw a line to it, so we'll just look at the rest of nums 1. And then our nums 2 remains the same. Hopefully this makes sense. It's a little bit confusing. Essentially, we're just looking at, we're calling the top row nums 1, and bottom row will be nums 2. We're just going to go through each number in the top row, deciding whether or not to draw a line to another number in the bottom row. So if we look at the first number in the top row, that's going to be nums at index 0, nums 1 at index 0. We're deciding not to draw a line to it, but we need to move on to the next number in the list. So that's going to be nums 1 to the end. So our new list becomes nums at index 1 to the end. So we're going to look at 4 to the end here. Numbers 2 doesn't change because we're only looking at starting lines from nums 1. All right, so that's our first option. Then option 2. We'll start that at 0, but this one is where we do draw a line. So in option 2, we're deciding to draw a line if we can. We need to check to see if we have a matching number in the bottom row first. So we'll check to see, do we have a matching number from our current top row's first number to some number in the bottom row? If we do, then we can draw that line. Now, one other piece here to sort of realize, we might have multiple matching numbers in the bottom row. How do we decide which matching number to draw the line to? So based on our earlier observation that once you draw a line to a number in the bottom row, everything to the left of that number is out of bounds. We can't draw lines to it because we'll be crossing that current line. That essentially means that we want to keep our lines as far left as possible. We want to keep as many numbers still available for the rest of our array, so we want to choose the very first or the leftmost number that matches our current number here. So you need to sort of convince yourself that this is true. You can draw these out, but it might take a little bit of a leap of faith to believe that that's true. But you always want to choose the first available number that you can. All right, so do we draw the line? Well, first we have to check if we can. Let's see, I'm gonna actually let's make this a little bit easier here. And we'll just be nums 1 at index 0. So this is the number we're looking for. If n is in nums 2, well, then we can draw a line. And we definitely want to draw it to the first one we get, so we can get the index by saying index is equal to nums 2, index of this number. So that should return the first index of the number n in nums 2. Now that we have a matching number and we have the matching index, now we need to adjust our recursive call here. So now our option 2 will be equal to 1 plus our recursive call, because we just drew one line, so we get to add 1 here, and then we have to do our recursive call. Again, we are advancing our nums 1 because we've used up this number at index 0, so nums 1 goes from 1 to the end, but nums 2, we've also used up the number at this index, so we have to go from index plus 1 to the end. And finally, our result here, well, that's just going to be the max of option 1 and option 2. All right, so hopefully this makes sense. We have a recursive function. We're going to check first, do we have any numbers left in nums 1 or nums 2? If we don't, we're done, we return 0. Otherwise, we have two options. Option 1, we just ignore this first number in nums 1 and we recurse on the rest of the numbers. So we decide not to draw a line from this first number. Option 2, we do draw a line, but first we have to make sure we can. So we check to see if we have a number in our nums 2. If we do, we grab the first one, we draw our line, so we get to add 1 to our result, and then we do our recursive call using what's left of our nums 1 and what's left of our nums 2. At the very end, we just choose whichever option gives us the best answer. the max of option 1 or option 2. All right, let's see if this works. And it works. So let's see how we do. And we get a time limit exceeded. We do pass 55 out of 74 test cases though, so we do all right, but we need to do better. So let's use this test case as one of our test cases. All right, what can we do to speed this up? So recursive functions are generally slower, so we could try to make this an iterative function, but that's going to take a lot of reworking here. What are some things that we can do to just speed up this recursive function? So the first thing I can think of here is these nums1, nums2, we're doing these slices each time, creating essentially new arrays that we're passing down through. That's going to take some time. That's not cheap. The other thing that we're doing here is we're not caching our results. We're not doing any type of dynamic programming or caching. So that's going to take up extra processing time because we'll be calling the same function multiple times using the same inputs, but running the entire function again. Now, we can't really cache this function as it is because these nums are lists and you can't use caching on lists. But what we could do is instead of actually passing new lists each time, we can keep track of our index in the list and just pass the indices of each list each time. So let's do that. Okay, so I'm creating a new internal function here, max uncrossed lines recurse. And instead of taking an entire list here, we're just going to take the index into list 1 and list 2. That should save us a lot of time. For this, we need to know what our max indices are so that instead of checking if these number lists are empty, we can check to see if we've exceeded the bounds of our lists. So in this case, we'll check if index 1 is greater than max index 1. And same thing for index 2. All right, so if we're out of bounds on either of our lists, then we can return 0. We're done. Now this one, option 1, instead of calling max cross lines itself, we're going to call max cross lines recurse. And instead of passing a new list starting from index 1, we'll just pass in our new starting index, which will just be I1 plus 1. And our index for nums2 is just index 2. We're not changing that index. Okay, now down here. In this case, it's not going to be the number at index 0 anymore. It's going to be the number at our start index. So n is equal to nums1 at I1. And now we can't just check to see if the number is in nums2. We actually have to check nums2 from this index to the end. So we are doing a little bit of slicing. This might be too slow for us. And let's see, this index, again, we can't use the entire nums2 anymore. We have to look at just from I2 to the end. And then instead of calling this main function recursively, we'll call our special recurse function. And then this time, we'll be passing in I1 plus 1 and just index plus 1. Now out here, we still need to make our initial call. So we'll just do our initial recursive call, passing in index 0 for both. Okay, and we don't actually need this result here. We're not using it. So let's get rid of that. All right. So this is essentially the same function as we had before, but instead of passing in new lists each time we recurse, we're just passing in the new starting index of our list. All right, let's see if this works. And we still have a time limit exceeded. So this still isn't fast enough. Well, now that we've changed this to just use indices, we no longer have to worry about lists. We can actually make this one a cached function. So caching is just a way to decorate a function so that if you call the same function multiple times using the same inputs, it will just cache the result and return the cached results instead of having to rerun the function again. So let's see, from functools, we'll import cache. Then here, we just decorate this with @cache. Okay, let's see if this helps. Oh, but this is giving us the wrong answer. So what's going on here? Why is this giving us the wrong answer? So I think what's happening here is this index is now the index into this nums2, which is not really the index into the entire nums2 list, which means that this index isn't really the right index for the recursive call. We need to actually find out, let's see, I think we just need to add I2 plus. I think that should do it. Let's try that. Okay, so that's the problem that we were running into. That's a little bit confusing too. So in our recursive call, this initial index has to be the index in the main list, this nums2 list. But when we're calling this find that we're doing, this index here, is going to be the index in the truncated nums2 list, or the shortened nums2 list from I2 to the end. All right, let's submit this and see if we can pass all the tests. And we do. All right, so we pass and we beat 32% for runtime and 17% for memory, so not too bad. Let's jump back and do a really quick fix to see if we can speed this up. All right, so one thing we're doing is we're doing this find each time. We're basically saying, look for this number in this array. Now that's going to be a little bit slow because we're going to essentially traverse that array multiple times just trying to find the index of a particular number. What if we just created a mapping at the very beginning that mapped our number to all the indices where we might find that number? Then anytime we're looking for that number, we just can jump to it instead of having to do this whole find again. Let's do that. All right, so we have a mapping. That's just going to be a default dictionary. And it's going to be a list of all the indices of this particular number. So the key will be the number, and the value will be a list of all the indices where you find that number in list 2 or in nums2. All right, so for n in actually we're going to have to enumerate this. So our mapping for this number will append this index. Okay, so now we have this new mapping where we can give it a number and it will give us back a list of all the indices where we find that number in list 2, in nums2. All right, so that's pretty awesome. Now let's write another function here that will help us, because one thing that we're going to have trouble with is actually once we grab that index, we don't want to use just the first index that we get back in that list. We might have been past that index. We actually have to do a little bit of work to find the right index here. So let's do a find index. And let's see, it'll take the number we're looking for and some start index. All right. I guess the first thing we'll do is just check to see if we even have this number in our nums2. And we'll just return 0. No, because 0 could be a real index, so we'll return none if we don't have this number in our mapping. All right, but if we do have the number in our mapping, then we need to find the first index after start where that number appears. So let's see, we can say for so our find index will first look to see if we have this number in the mapping. If we don't, we return none. If we do, then we'll go for every index in our mapping. And if that index is greater than or equal to this starting index, that means it is some future instance of this number n, then we can return that index. If we don't have any indices that are greater than their start index, then we'll return none. All right, so then down here, so instead of checking to see if n is in nums2, we can just say, let's get the index. All right, so now instead of doing this find, we can just do our check here. We'll grab the index, we'll find the index for this number. If it's none, then we'll just move on. If it's not none, then we can use that index to do our same recurse that we did before. So this does the same thing as that index does on our nums list, but it just does it faster. So let's just see if this works. Let's see, find index is not, we're down to 1 minute, so hopefully this will fix it. Oh, I need to pass in the start, so that's going to be I2. There we go. And let's see if this gives us any kind of boost in our performance. And it does. So we do all right. We beat 88% for runtime and 17% for memory. So that's a little bit of a boost. Let's see, that's up from 32%. Oh, that's a pretty decent boost, but it's still not a 90. I was hoping for more. Well, that's it for me. I'm out of time. So check this one out. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.